Hey, what's going on everybody? Today we're going to be taking a look at the setup for a TP-Link Omada system. This is going to be a full network setup slash kind of review or showcase of the TP-Link Omada products. Full disclosure, I was sent 3 items from TP-Link to go over, make a video about, kind of show off the features and a little bit of how to configure it. We're basically going to be comparing it directly to UniFi because that's what I'm used to. If you've watched videos on this channel, you know I cover mostly UniFi stuff, but there's some TP-Link Omada stuff in there as well because they're kind of competitors. So we're going to see how easy this is to set up, what it does maybe better than UniFi or worse. But basically I've got these 3 devices here that I was sent from TP-Link. We got the SG2008 switch, the ER7206 router, and the EAP653 access point. Now the idea is to set all this up like you would any network in production. So we're going to think of this as an entirely new site. Say we just got a new house or we're setting up a new business. We're going to configure the router for internet access, configure the switch so we can use quite a few different devices, and then obviously the access point so we have wireless. Now one of the main features that A, TP-Link wants me to talk about, and B, I think is interesting, is what is called the Zero Touch Provisioning ZTP, or basically unboxing not required feature of these Omada devices. And what that means is that basically you can adopt them into a controller just by scanning the serial number on the box. You don't even have to open it. And then you go into your Omada controller, preset everything up, so that way they just work out of the box. Now this feature might not be that great if you're a home user because you're going to obviously get all that equipment and unbox it, set it all up yourself for your own home. But if you're a managed service provider or someone else who manages IT for any other company, this is pretty cool because your main IT staff can just receive the products in, or they don't even have to receive them as long as they have the serial number for them. They can just configure everything in an Omada controller instance, give the boxes to somebody else, and they just hook it up and it'll work right out of the box. No configuration on site required. And TP-Link's not the only people who do this. You can accomplish almost the same thing with UniFi. But one of the main things that goes along with this is that TP-Link offers a free cloud controller instance. So if you're kind of familiar with the whole software-defined networking controller controlling all of your network devices, you know, typically you have one of a few different options. You can install the controller software on a server or a PC somewhere. You can buy a dedicated hardware appliance, think UniFi Cloud Key or the Omada hardware controller like the OC200, or you can have a cloud-hosted controller that is essentially the same thing, just located somewhere on the internet. Now, UniFi has a cloud-hosted controller, but it's like $30 a month. TP-Link's selling point is that they have a cloud controller, but it is free. You don't have to pay a monthly subscription. Now, there's caveats to that, which I found out while looking up this video, but you still get a cloud controller instance for free. So let's go ahead and just jump in here. Now, I haven't obviously unboxed any of these products, and I haven't set up a cloud controller instance. I'm coming into this fresh so we can kind of see exactly how easy this is to really get off the ground if you've never messed with it before. Now, obviously, I have messed with Omada before. I have TP-Link access points at home, and I'm using the OC200 as the controller. But what I haven't done is any of this zero-touch provisioning stuff. I haven't used their cloud services at all. So this is going to be pretty fresh for me as well. So first thing I'm going to do is just go to Google and just look up TP-Link Cloud Controller. And this first link here looks like it should be good enough. Omada Cloud-based controller, TP-Link. Let's go ahead and go here. And this really just looks like the product page. It says that it's new and it gives us all the information. But what I'm really looking for is how to set up a cloud-based controller. And we can see here, we can purchase the cloud controller now or learn more. Let's look at purchase Omada Cloud Controller now, see if that gets us anywhere. Well, first we need a TP-Link ID. Alright, so I logged in with my TP-Link account credentials. Obviously, if you don't have a TP-Link account, you're going to have to create one. But once you've done that, you're dropped into this homepage. And this will show you all of your cloud-based controllers, as well as any on-premise systems if you wish to add them in here. So what I could do is add my on-premise OC200 controller to this cloud management. or I can just set up a new cloud-based controller, which is what we're going to do today. So let's go ahead and add an organization, and we're given the choice between Omada Cloud Essentials and Omada Cloud Standard. So here's that caveat that I was saying before, where TP-Link has the option to have a free cloud controller, but there are limitations, and you can see a few of them here. So the Omada Cloud Standard, you can see it says abundant security features. You do not get the ability to configure things like IPS and other advanced security features with the Essentials controller. Basically, the free version, which is Omada Cloud Essentials, gets you the bare basics that you need to set an organization up. It does not get you all of the bells and whistles or the full feature set that you may want. And you can also see there's a compatibility list, which we looked at earlier. And these are all, again, the devices that are supported by Cloud Essentials. So what I gather from this is that there's only certain devices that are going to be able to be on the essential list. Other devices probably need standard. And if we select standard and hit next, well, it's still going to take us through this, but there is a cost associated with a standard controller versus an essentials. And if you want more information, there is a page, Omada Cloud Essentials Managed Products. This kind of gives you the whole overview of the Omada Essentials program, what you're supposed to do, log in with your TP-Link ID, which we just did, add the essential cloud-based controller. But at the very bottom of this page, after you go through pretty good guides on how to get it set up, you get to the different versions of controller that you can use. So you've got Omada Cloud Essentials, free, that's what we're setting up today. Cloud Standard, which has a device license fee. Not exactly sure what that is, but there is a fee associated with it. And then you've got your hybrid, or what everybody is probably already used to, your software controller that you install somewhere, or your hardware controller like the OC4, 3, or 200. And they have these listed under pricing as the hardware costs varies for every site, but you have free cloud access. It's also what I showed you over here under the on-premise systems. You can link them to your cloud account, manage them remotely. That is free. Hardware obviously is not. Software controller requires a constant PC server operation, and it also has free cloud access. So really, the software controller gets you the full feature suite, but you have to run it somewhere. But if you're running it somewhere, you have free cloud access to it. And if we scroll down even further, we can kind of see all of the features that each one of these modes supports and what they don't. So this is zero touch provisioning, which is kind of they call it a hero feature. It's the kind of the one feature that makes this Cloud Essentials real special, is that zero touch provisioning, where you don't have to unbox any of the hardware to set it up. That is not an option on your on-premise controllers like the hardware or the software one. Now, also, hardware controller nor Cloud Essentials supports MSP mode for multi-customer management. So if you're doing this as a service, getting paid for it, operating like an MSP, you're either going to have some sort of fee applied with a standard cloud controller, or you're going to have to go with a self-hosted software controller. Now, scrolling even further down, some things that I think are probably the most important is down here under security. Cloud Essentials, you cannot configure, at least that's what I gather from this. I haven't been in there yet. We haven't set it up yet, but it looks like you cannot configure access control lists, IPS or IDS, or deep packet inspection. And that is missing only from the Cloud Essentials package. You get that with standard, you get that with a hardware controller, and you get it with a self-hosted software controller. You also do not get packet capture for troubleshooting. You only get basic logs, there is no API, and there is no wireless LAN optimization. So if you're curious about exactly what you would want, definitely take a look at this list and realize that there are limitations to the Cloud Essentials free version. Now, I am a little curious on what this device license fee would be with the Cloud Standard. Haven't set that up, haven't looked at it, but I wonder how competitive that is with Ubiquiti's cloud hosted controller, which I believe, at least the last time I set one up, was $30 a month. And that's a flat fee up to a certain amount of devices, which used to be 500, now I think it's 100. So I am curious what that fee would be. But let's go ahead and keep going with our setup for Cloud Essentials. So we're just going to choose the Essentials version, click Next, give ourselves a name. We're going to say it's Toasties Test Organization. Yes, we're in the United States. We are not on Pacific time. We are on Central time. Accept the terms, of course, without reading them. Why not? And then we're put into kind of our overview, how to use the thing slideshow. Now, this looks different than a regular Omada controller, but everything is more or less the same. You've got your global mode and your sites. So if you're used to the controller, you have one page that shows all your different sites. You go into the site, you can manage all the devices for that specific site. But in global mode, you're basically controlling the controller itself and moving between sites. So that's what this is showing. You've got the global view here, dashboard, my account, whatever. If we just kind of click through here, it tells you stuff about how the users work, how there can only be one main administrator, but you can have multiple sub-administrators, your site overview, what each of the tabs do, yada, yada. If you're unfamiliar with Omada, definitely take a look at this. We're just going to kind of gloss over it for now. And we'll go ahead and exit out of these boxes that say something about the version. Now, let's go ahead and try and set this up. So we're going to add a new site. Right now, we're in global view. So if we had multiple sites we wanted to manage, we would add them here. Let's go ahead and set our first one up by clicking Add New Site. We're just going to name this Toasty's Main Site. We can apply a tag if we want. I'm not going to. Yes, it's under the same time zone. And we get to select what kind of switches are going to be here. So if we have easy managed switches, we'll check it there. You'll probably know if you have an easy managed switch because they're named as such. The hardware we have today is a smart switch. We can select application scenario. This is that thing that in my other videos, I'm still not entirely sure exactly what these change in the background, but we're going to say we're in a home scenario for today. And we're going to give our device accounts a username and password. So the device account is what you would use to log in to the specific devices that are a part of this site. So if you're going to directly log into or adopt devices to this controller under this site, you're going to need to use this username and password. So I'm just going to go simple. Obviously, make this as complex as you need to, but I'm just going to use admin and password 1234 for testing purposes. And it looks like they actually have a password complexity requirement. So we'll do password 1234 exclamation, see if that passes. And it looks like it does. Address, latitude, longitude, that's all optional. If you want to put that in, you can see it on the map, nice and pretty. We're not going to worry about that for now. We're just going to hit apply. And now we have our first site, Toasty's Main Site, ready for configuration. So let's go ahead, just click on it and jump in there. And this is an entirely blank controller, so no connected devices found. Let's go ahead and add them. So this is where that zero touch provisioning or no unboxing required feature comes in. And this is where we are going to switch over to our mobile app. And if autocorrect would stop correcting me, we could look for Omada. And if we scroll down here, TP-Link Omada is the app that we want to download. I had mine uninstalled because my phone filled up on storage, but we'll go ahead and re-download that and open the app. Go through all of this that's talking about the changes and close out of the pop-up that wants to allow network connectivity. Now, in this app, I already have my home Omada controller in here. I don't have it cloud managed, so that's why it doesn't show up in the account on the website. But you can see we already have a cloud-based controller showing up in our app because we're signed in with the same account. So go ahead and tap on Toasty's Test Organization, and we're brought to the global page. Go to Toasty's Main Site, and now we are in the controller. Now we have the option to add a device, so we're going to go ahead and tap that, and we have the option to scan to add. This is what we want to use. So we're going to go ahead and add our cloud gateway first. So use the scan to add feature, allow access to our camera, and all we got to do is scan the serial number. It pops up, and we hit add this device. Device is added successfully. Go ahead and click done, and we'll do that for all of our new devices. And again, I haven't unboxed any of these. They're not even open. So now we'll just scan our switch, I believe. Just kidding, it's the access point. But here is where, oh, nope, it's actually going to add it. Sometimes the plastic on these boxes likes to interfere with the scanning process, but that looked like it worked just fine. We'll go ahead and click done on this one and add our last device, which is our switch. Add this device, and we are done. So let's go ahead and go back to our computer session, go to the dashboard of Toasty's Main Site. And you can see we have one gateway and one access point. Now the switch is showing 0, probably just because I just added it and this isn't updated yet. So I'm going to refresh the page and it still says 0, but let's go to the devices tab And yeah, it shows up. So if I go back to dashboard, that's probably going to say 1. Don't know why it's not saying 1, but switch, access point, and our gateway are all added. And you can see the status is pre-configured. So this is a status they'll be in if they haven't been unboxed and you're using that zero-touch provisioning feature. So let's go ahead and just give these devices a name. At this point, we're going to set these devices up as if they are already connected on the internet, installed in the site, or whatever. So all the configurations we do here supposedly are going to be pushed directly to the devices once they are unboxed and plugged in. So I'm just going to go ahead and give them names real quick to easily identify them. I'm going to call this one Toasties Switch. We can modify the VLAN interface, add a static route if we want, mess with services and whatnot, but actually I am going to change this rapid spanning tree protocol value to 4096. Since this is going to be the main switch of this new organization or my house or whatever it's going to be, we're going to change that. Now, if you're not sure what spanning tree does, do not follow that configuration. It can mess some stuff up if you're not sure what you're changing. And I guess I forgot to hit apply under the name, so I'm going to go ahead and rename this Toasties Switch, apply, there we go. And now I've updated the name on all of them. So I've got the gateway, switch, and AP named and ready to go. So at this point, I'm going to start setting up our main network layout. Now I'm going to go a little bit advanced in this. We could set this up just regular straight out the box, but my kind of thinking with that is that the devices will more or less work in a default configuration anyway, as long as they're adopted. So we're going to set this up like we would in organization. We're going to have multiple VLANs, and we're just going to throw in a little bit of advanced configuration because I want to see if it actually all works right out of the box without any sort of other configuration. So we're going to go to the site settings. Well, not the site settings. We're going to go to internet settings, and WAN setting overrides is disabled right now. And this box says basically if this is disabled, it's going to use the settings that are set up directly on the hardware itself. That's not really what I want. I want this to have custom configurations right out of the box. So if we turn it on, then we can set up our WAN configurations, and this is what the gateway will pull once it's plugged in. Now for this, we've got to select our gateway model, and it gives us this drop down of all of the different models that we can choose from. And what this doesn't do, apparently, is automatically detect the one that we have in a pre-configured state. So we still have to manually select which gateway we have. And the one we have is a 7206. However, I don't know if that's a version 2, a version 2.2, or a version 1. Let's go to the devices and just see if that's actually going to tell us what it is. Oh, and it does. Model 7206, version 2.26. So let's just remember that, 2.26. Go back to the internet, turn our settings on, and select that from our gateway model drop down. So 7206 version 2.2. We're on 2.26, but this is the latest one. And then here it has us select our WAN port. I'm just going to leave this default. We're going to use the SFP WAN and WAN 2 as our WAN ports, but you can assign more if you would like them. And here it has us copy WAN port settings. This is a little weird. I guess it thinks that the current gateway is an ER605, even though we don't have one. And our new gateway is going to be that. So we're going to copy, sure, current WAN settings to our regular WAN port. I guess this is just saying which one do we want this internet settings to apply to. I don't know. We'll see later. Go ahead and click apply. See if there's any other settings that we need to change here. Can set load balancing, but we're not configuring two WANs. So yeah, everything looks fine here. So we're going to go ahead and go from internet to LAN. Basically, let me just kind of clarify. These WAN settings for the internet mode, this is basically just for the gateway and the interface that we're going to connect to the internet. And if we needed a static IP or anything like that, we'd come down here to the one we set as our WAN port, click the edit button. We could give it the description. We can change this from a dynamic to a static IP and put that information all in here. Now we're going to be using a dynamic IP because this is in a lab environment. We're not going to actually get a public IP. We're just going to be using a DHCP server that's automatically, or not automatically, already existing. And a lot of WAN connections are DHCP anyway. Obviously, this is targeted towards businesses, and businesses do have static IPs, so this would be where you'd put that in. but I'm going to cancel out of that and just leave that at the default. Now we're going to go set up our LAN. And this is where we are going to configure all of our different networks and VLANs and whatnot. So VLAN 1, we'll leave as default. We'll say this is our primary network, but we are going to change just a few of these options to make it a little more complicated. We'll change the name from default to main LAN, and its purpose is going to be an interface. Now the difference between interface and VLAN is if you have it set to interface, it's going to be managed by your gateway device. If you don't have a gateway device, you can just set it to VLAN, and that's just going to apply to the switch basically. But we want this to have the actual gateway device used, and we can assign it to all the interfaces or just specific interfaces. I'll go ahead and leave it on all of them. We'll leave it on VLAN 1, but we're going to change the gateway address to something dumb like 10.88.55.1. And that's going to automatically populate DHCP settings. If we want these to be different, which sure, let's be complicated, we can change the DHCP range down here. I'm going to say 55.100 to 200 can be our DHCP range. We'll skip the domain name, we don't need it. We can manually set DNS server. Nah, we're just going to leave that as auto. Default gateway we'll leave as auto as well. We are going to enable what's called legal DHCP servers. If you're familiar with Cisco, this is basically DHCP snooping, and all it means is that a single IP address is the only one allowed to give DHCP. So this will kind of fight against rogue DHCP servers. You don't want another server in your network that you don't know about handing out addresses and messing everything up. So if we lock this down to 88.55.1, which is our gateway's IP, then it's going to be the only one that's allowed to send DHCP to devices on this network. And if we wanted advanced options like these, we could set them here. Not going to worry about that. We're not getting that advanced. We're just kind of getting a little bit advanced. Now it says ensure the configuration is correct, otherwise device may be unable to connect to the organization. Require a factory reset. Sure, we don't have anything configured yet, but we'll go ahead and confirm it. Now let's go ahead and set up our other VLANs. And for this approach, we're just going to use kind of a standard wireless VLAN, security VLAN, and an Internet of Things VLAN. So let's create a new one. We'll call this one internal wireless. It is going to be an interface because we want it managed by our gateway. Go ahead and select every interface. We'll give it a VLAN of 10, and we'll say this is 10.88.56.1, and it's a /24. We'll update the DHCP range, 10.88.55.100, 10.88.55.200, enable legal DHCP servers. If I didn't mention it before, this setting can be dangerous because if you misconfigure it, you won't get DHCP, which I actually just noticed that I did misconfigure this. I put 55, which was the IP address of our default interface. So let's make sure that's good to go. Looks like it is. And we'll go ahead and save. Now let's just quickly make our other ones. We'll do IoT, assign it to all interfaces, give it a VLAN of 20/24, change our DHCP scope, and enable legal DHCP servers. Save that and create our last interface, or LAN, which is going to be guest. Give that a VLAN of 40, give it a new subnet, and DHCP snooping. Now I don't see a kind of network type that labels this as guest. I forget exactly where that is, but I guess it's not here. So save that, and we've got all of our VLANs or LANs set up. Got our main LAN 55.1, internal wireless 56.1, IoT 57, security 58, and guest 59, and all of our VLAN numbers over here. So looks like our LAN section is pretty good to go. That's all set up. So let's move on from our LAN to our wireless LAN and set up our SSIDs for this. Now we'll create a new wireless network. Let's do toasty-wireless, and the device type is going to be an EAP. I'm a little confused on why gateway is an option here. It says the gateway device type does not support certain functions. I'm assuming you would select gateway if you have the device that's like a wireless gateway, which I believe I saw here on the on the supported products page, there is a Wi-Fi gateway that is both a gateway and a wireless access point. So I assume that you would select the gateway option if that is the device you're configuring. We're not doing that, so we'll leave it unchecked. Now, what bands do we want? 2.45. We want 6 gigahertz here as well. This is not going to be a guest network, so we'll leave that unchecked. And WPA personal for our key, we'll just do kind of our same default testing password, password1234 exclamation point. And we do not want this on the default VLAN. So if we left this as default, it would be on VLAN 1 or our main network. Typically that's what you would do anyway for internal wireless, but we're being difficult and we're going to change that to custom, and we're going to add a VLAN by network. We can either assign a network or just straight VLAN ID. Either of these would work, but by network would just be cleaner. So we're going to go ahead and select our internal wireless LAN as the VLAN, which corresponds to VLAN 10. Scroll down and see if there's any other settings that we really want to change. There isn't really anything that I would like. Data rate controls we can play with if there's wireless issues. This is all kind of after the deployment part. So we'll go ahead and apply. Now we've got our wireless network, Toasty Wireless, but we also want a guest network. We're just going to name it guest. And we'll say it gets all of the frequency bands as well. Now we are going to enable this guest network, and it says with this option enabled, it'll prevent wireless clients on the same AP from communicating with each other. And it also lets you know that it may restrain functions of AirPlay, Chromecast, or Sonos, screen mirroring, or other things. Basically, if you need to communicate with other devices on the same LAN, it's not going to work with guest mode enabled because they're physically, no, obviously they're not physically, but they're at layer 2 isolated from each other, which is what we want on a guest network. So we're going to enable that. We'll give it the same password. Actually, we're just not going to give it any password at all. We're going to leave this one wide open, but we are going to give it custom VLAN of our guest network that we configured just a minute ago. We'll leave all the rest of this the way it is and hit apply. So we got 2 wireless networks in our organization now. We've got Toasty Wireless and Guest. So some other stuff that we would want to set up. Let's see. I would really like to set up firewalls between all of these. Let's see if that is something we can do. I know that it said access control lists are not allowed in the Cloud Essentials, but let's just see if we can find something that's a little bit kind of like that, because I feel like that's a pretty big feature to omit. While I'm just looking through stuff here, I'm going to change some of these wireless features. I do not want mesh. If I wanted mesh, I would leave that enabled, but I don't want it. LLDP we want, fast roaming, sure. Non-stick roaming, what is this? Helps disconnect sticky clients receiving weak signals from their wireless device. That sounds pretty cool. I wonder how well it works, but we have a single AP for this deployment, so that really doesn't apply. And we'll leave band steering, whatever. Now here is that device account that we set up during the initial setup. It says our username is admin, password1234 exclamation point. If you did want to change that, this is where you would, but we'll go ahead and save our change to the mesh. And the reason I'm disabling mesh, even though we have a single AP, is because at least with other devices, I don't know if TP-Link is the same, but sometimes when mesh is enabled, it's actively looking for other devices to mesh with, and that just uses up unnecessary energy and airtime and whatnot that we don't need because we don't plan on having a mesh system. Now let's go ahead and set some device specific settings. So something that I like to do is hard code channels, especially if we had multiple APs. I know we only have one, but we'll go ahead and go to the config mode of Toasty's AP. We'll go down to radios, and we're going to change the channel width to 20 megahertz for 2.4. And it looks like we don't have channels available. No available channels. Please check your channel range and bandwidth configurations. Interesting. Transmit power we'll leave on auto, so we'll go ahead and click apply. Now where is this channel range and bandwidth configuration? Bandwidth control, maybe, for transmission? That doesn't look right. Well, not actually sure if that's some setting that we need to change elsewhere or just something that'll update when the access point comes online. So we're discovering things together here. Usually I would hard code the channel, but I guess it's just for some reason not letting me for some reason with the device not active. So let's move on. and we're going to move to the switch. So with all these VLANs, we're going to configure, or see if we can configure, certain ports for certain VLANs. So we're going to go to the ports tab of the switch. Port 1, we'll go ahead and edit that. We'll say that this is our main desktop, and we can apply a port profile. We're going to say this is only going to be able to access the main LAN. We'll apply that. Port 2, we're going to edit. We're going to call this our wireless access point, and the profile we could stick with all because it's going to pass all the different VLANs, but we're going to go ahead and manage profiles and create a new one for wireless access points. And all this is going to do is create a profile that only allows certain VLANs. So we're going to keep device settings for PoE. Native network is actually going to be our internal wireless because we don't plan on pushing the main network over wireless, and our tagged network is going to be guest. So with this profile, if we had a voice network we could put it here, but with this profile, the way it's configured, our native VLAN for the port is going to be internal wireless or VLAN 10, and we're going to only be tagging VLAN 40. So none of our other VLANs we configured are going to pass over a port configured with this profile. So our security, our main LAN, and our IoT are not going to be a part of this. And I do realize we made an IoT network, and typically you're going to have a wireless network for that, but we'll ignore that for now. And we'll go back to the device, Toasty switch, ports, and reconfigure port 2 for wireless access point, and we're going to assign that profile we just created, which is wireless AP. And we'll go ahead and click apply, and we'll just create some other ports for our different VLANs. We'll call this one IoT, give it the profile IoT, and security, give that port profile of security. So the way our switch is set up now, we'll have our main desktop on port 1, which will only be a part of the main LAN, our wireless access point on port 2, which has a custom port profile to allow our internal wireless as the native VLAN with our guest network as the tagged VLAN, and then we have a couple other access ports, if you will, for IoT and security. Now the last one we're going to do is port 8. I wonder, yeah, there is no specific profile to give it for an uplink, but this is going to be our gateway uplink. So this is what's going to connect to our router, the Toasty's gateway device, and we're going to leave this one as profile all because all of these networks that we have configured currently are going to be serviced by the gateway, so they're going to have to pass. And we'll go ahead and click apply there. Now what else should we configure? Actually, I do have one other thing, and it's a whole new VLAN that I for some reason looked over. A lot of businesses or enterprise environments would use something like a management VLAN. So let's go ahead and set one of those up while we're here. So we're going to go to, I went to internet, that was the wrong one. We're going to go to the LAN section, and we're going to create a new LAN. This one's going to be VLAN 50, and we're going to call it management. We'll go ahead and assign that to all of these, give it our VLAN tag of 50, and I believe the next available address was 60.1. I'm doing all this configuration and testing and realizing that a lot of stuff is just kind of gross. Typically I want my VLAN tag to match, and none of the VLAN tags match. That's going to bother me, but this is just demonstration purposes. If I put a little more thought into my layout, it would probably be better. I'm going to go ahead and save that. Now we're going to apply this to all of our devices. So Toasty's gateway, if we go to config, go down to, where was it? Is it networks? Here we go. Config VLAN interface. So this VLAN interface is the one that's going to be managed. So we're going to change this. Okay, I don't mean this is going to be the management interface exactly, but this is which networks are going to have a virtual interface on this specific switch. And I only want management because I only want to be able to manage it from the one. So we're going to go ahead and apply. Network cannot be disabled because it has been configured as the management VLAN. Okay. So we have a specific configuration for a management VLAN. Let's see, was that in our LAN settings? Let's look back at the main LAN configurations. I do not see an option for management VLAN. Maybe that's located somewhere else. Let's see, site settings maybe? Nope. Let's see, I'm gonna go back to the device. We'll go to ports. Actually, let's config. Okay. I'm Googling something in the background just to see how to do this because I'm used to Unify where there's an actual management VLAN drop down and you select which one you want to be management VLAN. But I guess for this we have to go to VLAN interface, enable both of these. So we'll go ahead and apply, edit our new management VLAN configuration and enable the management VLAN. So this is what's going to assign VLAN 50 as management for this device. And we can configure a fallback IP address if for some reason it doesn't get it from DHCP. And we could also give it a fixed IP address, which typically I would do for these. And I guess since we're doing an advanced configuration, I will anyway. So I'll call an audible here. Management 10.88.6D dot, we'll say 5 for our switch. And we'll go ahead and apply that. Got it. And since this is a switch, we probably do need a static route. We'll go ahead and add 0000/0. Next hop is going to be 10.88.60.1. And we'll go ahead and enable it. So apply. This is basically just so the switch can communicate out in case we want to manage it on another VLAN. And while we're at it, we'll go ahead and disable main LAN VLAN interface because we took management away from it. Now, let's go ahead and update that on these others. I don't think the gateway actually, it doesn't need this setting, so it probably doesn't have this setting and doesn't look like it. So gateway we don't have to worry about, but the access point we are going to put on the management VLAN. So IP settings, we'll also use a fixed IP address on the management network, 10.88.60. We'll say 10 for our access point. Go ahead and apply that. And for the services, the management VLAN, we are going to change from default to custom, and we're going to select management. Apply, got it. All right, so at this point, I think we're good to go and say that we can deploy this network. So now we're actually going to unbox the devices, plug them in, and see if they get all these configurations and if all the configurations work. I wanted to go pretty advanced with this so we could just test and see how viable it is to actually deploy it into a business environment. I know that there's a lot of settings that I've configured that I haven't explained. That's probably something for another video. Let me know if there is any specific configurations you would like me to go a little deeper in depth, but this is really just to show a sample setup for an Omada network and to test this zero-touch provisioning feature to see how awesome or not awesome it is. So let's go ahead and jump into the unboxing. Alright, so we're just gonna unbox these devices, starting with the switch, and then the access point, and then the router. And I'll just go ahead and plug all these in and cable them up. So we're going to the WAN port on the gateway from this blue cable, which is our simulated internet service provider or our internet connection. And then we're going from any of these other ports on the gateway to our switch because we configured all of our networks on all of the ports. If we had selected certain networks for certain ports, then we would obviously want to match that up. But I'm just going to go from the furthest port to the right to port 8 on our switch, which was what we configured as the uplink. Now for the switch, I'm going to use port 2 for the access point, and then port 1 is going to go to our test machine. So now that everything is powered on and connected hopefully to the internet, let's go back to our controller and see if there's any changes. So all of our devices still say that they're in the pre-configured state, but let's try and refresh. Okay, we have two devices, our switch and our gateway, in the configuring state, and our access point still says pre-configured, and actually the access point didn't power on. And I just need to look at the box for our switch. I don't actually remember if it was PoE or not. The front of the device says PoE input port, but the back of the box says that all the ports are data only, so I'm a little bit confused there. But just judging by that, I do not believe that this switch supports PoE for this access point, so I'm gonna have to power it another way. And luckily for me, I have power injectors lying all around, so I can actually power this up without PoE on the switch. It's probably something to keep in mind is that this access point actually doesn't ship with a physical power supply. You have to have PoE. Now also, one thing I'm noticing here is that the IP addresses that are popping in for the gateway and the switch look like the fallback addresses. So let's go to Toasty's switch, go to the config, and just take a look at the IP configuration, because they're connected to the internet, obviously, because they're in the configuring state, which makes me think connectivity is fine. I don't think they'd be able to communicate on the fallback address like that. Actually, just refreshing the page, never mind, the switch does say that it's at 60.5, which is our statically configured address that we put on it. But the gateway still says it's 0.1, but it also says it's still in the configuring state. So let me just hook up my PoE injector real quick for our access point. All right, and I've connected the PoE injector to our access point. I'm just waiting on that to show online here in the controller. But the other two devices, after powering on and cabling up, looks like they got the IP addresses that we configured, 88.55.1, 88.60.5. Now let's take a look at our IP configuration on this test machine. Just do a quick IP config. Looks like our Ethernet 2 adapter still has not got an IP address, which that's the one that's connected to our TP-Link equipment. So let's go ahead and release the IP configuration for Ethernet 2 and renew it. And there we go. We got 10.88.55.100, which is the first address in our DHCP lease pool. Right now, it looks like everything is working as intended. All we had to do was take it out of the box, plug it up, and it immediately came into the controller. So yeah, zero touch provisioning, pretty cool. But what all, let's see what all I can ping from here. Probably every interface on the gateway, I would imagine. Let's see, 56.1, yep, we can ping that, which I think was our IoT interface, 57 and 58. So I can ping all of our interfaces that we configured. Let me just refresh the device page real quick, see if we got the access point in the mix, and we do. Toasty's access point. Right now it's configuring. It says it has an address of 56.100, which is actually 56. Yeah, that was our internal wireless network that we created, and because that port has that as the native VLAN, that's going to be the IP address it initially has. Once this is done configuring, this should switch over to the 60.10 IP address, which we configured for management. Now, typically when you have all these different VLANs configured, you want to put firewall rules between them. I already mentioned that before. So like right now, this test computer is on our internal default network, but we have a management network of 60. So let's say 60.5. If I ping that, that's the switch. So if this was a real setup, I would ideally want the main networks or any network that's just going to be used for regular data to not have access to the management network. And this is where I think the limitations of this free controller are going to come into play, because there's not really any security settings here. So we have all these different VLANs. I could configure them before the devices were deployed and they were applied properly, but I can't lock down the access. So having all these different VLANs is just going to operate at a routing level, I guess. There really is no network segmentation past them being on different subnets. They still have access to and from each other. And I guess because of the free nature of this portal, you can't configure those access rules, which I think is that's a pretty big feature to not have in your free controller. Like, if you've got a gateway device that's capable of IPS, and I mean, obviously it's supposed to be used as a firewall, why would you not have firewall rules able to be configured? That just seems like a push to have you buy the paid service with the device licenses and all that. So while Omada does offer this free cloud controller, which is awesome, to me that's a glaring omission from what you're able to do with it. Like, I understand some features not being accessible. Like, I could understand IPS, even though that's still a stretch. I could understand that not being in here, but basic firewall rules not being able to be configured on the free service is a little, not sure why that decision was made, except for to have you pay for the standard cloud controller. But let's go ahead and look at the logs. We got something, WAN is down. Okay, it actually isn't. Clients, we've got our lab PC here. Again, 55.100, it's on switch port 1. And then we have this guy, which I believe is the access point. I think it's either the access point or the gateway or the virtual interface on the switch. Our access point is still configuring, so we can't really get to that yet. I'll just give that a little bit to show up in the controller, or not show up, to finish configuring in the controller. Okay, so it would appear we have a problem with our access point. So it went from configuring, but then went straight to disconnected instead of connected. So I did go in here and I saw that it didn't save our static IP configuration. I went ahead and put that back in. That really shouldn't matter because it still should have grabbed DHCP from our management VLAN. And if I go down to services, our VLAN management is still set up for custom on our management VLAN. So let's look and see. I did check layer 3 accessibility because that's something that you need if you're going to manage the access point over on a different subnet than it is assigned to. That really shouldn't matter for this cloud controller. The cloud controller should still pick it up even without layer 3 accessibility enabled, but I went ahead and checked it anyway. So let's go look at the switch port configuration, make sure that was set up correctly and saved. So we'll go to Toasty Switch, and we put our access point on port 2. So if we go to our port manager, take a look at port 2, which we labeled wireless access point, we gave it the profile wireless access point. So if we go to manage profiles and take a look at that profile, we have internal wireless. Here's the problem. So we put internal wireless as the native VLAN, and our tagged network is guest VLAN of 40. So I think we set this profile up before I decided to throw the management network in, so it's not assigned to this port. This is what happens when you explicitly allow certain VLANs. You got to make sure all of them that you want are on there. So let's go to the tagged networks and throw in management. That is 100% why that is showing as disconnected after it configured. So let's save. Go back to our devices. We should see the switch starting to configure or provision, I would assume. Possibly not, just because it was a profile change and not an actual port configuration change. But let's just give it a minute here and see if it pops online. And there we go. It was about 30 seconds. It's back to the configuring state. So our access point should have been configured properly. It probably was. It was just that forgot to put VLAN 50 as a tagged VLAN on that switch port as a part of our wireless AP port profile. And now we're in the connected state. So everything looks great here. We do have 2 firmware upgrades that we could do. I'm not going to worry about that for now, but that is something I would definitely do. Production environment, this would probably be the very first thing I do next, but instead I'm going to go into our wireless network configuration and I'm going to make one change, and that is to the guest network, because I forgot that in my house I already have a guest network and it's only named guest. So just so that I can test this correctly, I'm going to change the name to Toasty-Guest. So that way when I test connectivity here in just a second, I'll actually be able to see the network and not just connect to the one I already have configured. Now if we go back to devices, for some reason our access point is in the heartbeat missed stage or status. Anyways, let's just go over to the phone and test our wireless networks and see what we've got. Alright, so heading to my settings and wireless settings, you can see we have 2 different new networks, and that is Toasty Guest and Toasty Wireless. So Toasty Wireless has a password, Toasty Guest does not. Let's go ahead and test Toasty Wireless. This just had the password of password1234 exclamation point. Go ahead and join, and it looks like we're just spinning here. If I go into the information tab, it looks like we're not getting an IP address through DHCP. Let's go ahead and just try our Toasty Guest network and see if that gets us anything. Yep, we got the check mark. If I go into the information, we received an IP address of 88.59.101 is correct. Not entirely sure why we didn't get IP address 100, but whatever, we got 101. If we go to speedtest.net, we'll go ahead and click go, see what kind of speeds we're getting. My internet connection should be 500 up, 500 down, so hopefully we are close to that. Now it looks like 230. That's acceptable in my book. Let's go ahead and go to the Clients tab on the computer while this is running. This obviously is my phone on the guest network. And you can see we're connected to Toasty Guest SSID. It doesn't look like I see the wireless band that we're connected to though. Well, I can go to online wireless and I can sort by the band. So it looks like we're on 5 gigahertz. We're not actually on Wi-Fi 6. And this entry here should have also been my phone for the regular internal wireless. So you can see we didn't get an IP there. We'll troubleshoot that in just a second, but our guest network is working just fine with acceptable speeds. So let's go ahead and try and switch back from Toasty Guest to just regular Toasty Wireless and see if we can get a IP address. And we're still spinning. So let's start troubleshooting. We're not getting DHCP, but we are getting it on the guest network. So why would that be? Well, the port profile could be one thing, but we did have VLAN 10 as the native VLAN. So let's just compare that to our LAN settings here. So VLAN 10 should be internal wireless. 56.1 should be the gateway and network address. So let's go ahead and edit this. Our DHCP pool is 56.100 to 56.200. It is enabled. And we have legal DHCP servers enabled 10.88.56.1. This looks correct. So I don't think it's our LAN settings. Let's go ahead and look at our wireless LAN settings and just confirm that. And if we go to Toasty Wireless and edit, we have the correct security key. Yep. Advanced settings, we have it on a custom VLAN, internal wireless VLAN 10. So what gives? And I actually think I might know why this one specifically isn't working. And I think it's because of how we did the port profile for this switch port. So first off, let me make this change just to confirm if it is what I think it is. So let's go to our settings and port profiles again, which I think was under LAN, is it switch profile? So let's edit the wireless AP switch profile, switch profile. And we're gonna change the native network. We're not gonna have internal wireless be our native. We'll just set this to VLAN 1 for testing, and we're gonna add internal wireless as a tagged network. Let's go ahead and save, see if anything needs to be pushed. Well, it didn't show anything pushed last time, but let's go back to the phone and see. Oh, yep, says we're already connected. Let's go to the information, and we have 56.101 as our IP address. And if we do a speed test, we should see pretty much the same speeds as guest because we're not rate limiting the guest network. And yep, 200 something meg. So we're good. Now, why did I have to make that change? Well, the way I configured it with VLAN 10 as the native VLAN kind of comes from me and my kind of networking habits. That's the way I usually configure access point ports. I put the main LAN that it's going to broadcast as the native, but typically that network is already the native on everything else as well. So the issue is, and let's just switch over to the whiteboard so this makes a little bit more sense. The configuration issue was that we had on the switch VLAN 10 was untagged and we were tagging VLAN 40 and 50, which was our guest and our management. And then on our wireless access point, when we had the wireless LANs configured, we assigned VLAN 10 to our internal wireless network. We assigned VLAN 40 to our guest and 50 to our management. Now, when the access point gets these configurations, it's going to go with what's configured on the network, which is that all of these with a VLAN number should be tagged. So when we set VLAN 10 to be untagged or the native VLAN, what was actually happening was anything that tried to connect to internal wireless was getting assigned a tag of 10. And because we didn't have 10 configured in the actual tagged section, there was a mismatch. The switch was expecting anything on VLAN 10 to be untagged. The access point thought it had to tag everything on VLAN 10. So when the switch receives that traffic with the tag of VLAN 10, it's like, hey, I don't have that configured as a tagged VLAN, so I'm just going to drop it. It's not going to place tagged traffic for any VLAN on its untagged interface. So that's why I had to remove VLAN 10 as the native VLAN in the switch port profile, put another one in its place, and add it as a actual tagged VLAN there. So hopefully that makes sense as to why that did not work. That was more to do with how I configure stuff and how I expect stuff to work rather than a problem with any of the equipment. But at this point, everything is set up and configured and looks like it's all working properly, except for the fact that the AP says that the heartbeat was missed. I don't know if that's a bug or something, because the changes that I made, like when I set up toasty guest versus just guest, it got that change even though it says heartbeat missed. So I'm not entirely sure what its problem is. Everything looks fine. I don't know. I'm just going to say that might be just a little bit of a bug. I bet if I tried to, oh well, I don't have the reboot option because it's in that state, but I bet if I tried to make some other change, it would probably go through. Anyways, let's just take a look at the dashboard, see what all stats we got. We got our only AP is the most active EAP. If we go to switches, we have our only switch as the most active switch. You can see we're split on our SSIDs. Can't believe I downloaded or uploaded that much data in that short amount of time. And then we have our client information. So as far as the whole system goes, that was pretty straightforward. Even though we had a little bit of an advanced configuration, it was still pretty easy to get everything set up, and it was definitely easy to just plug the devices in and watch them work, minus the couple of little hiccups that we had with me configuring things wrong. But like I said, this was a learning experience, and I was going to go ahead and experience it along with you just so we could see how easy of a setup it was, and it was surprisingly easy. So what are my overall thoughts after this setup? And let's just break this out into a list of like pros and cons. I'm going to go ahead and say that easy setup is a pro. And going along with that, the zero touch provisioning or no need to unbox equipment feature is definitely a plus. It worked very well. All I had to do was just install the app, sign in, scan some barcodes, boom, they were in the Omada Cloud Essentials controller. And as soon as they came online, they got all their configurations and started working as they should, with the exception of the little bit of troubleshooting that we had to do. Now the cons, I think my biggest con for this is definitely the lack of firewall rules being able to be configured without a paid subscription. So the biggest selling point, I think, for this is the fact that the Omada controller is free to be cloud hosted. You can go into this with just the equipment, no need to sign up for a subscription service, just get a cloud controller rolling, pre-configure all your devices, plug them in, and be good to go, which sounds awesome on paper, and it is very easy as you saw in this video. However, I think the fact that being able to configure firewall rules being left out of the free tier is a little bit crazy. And there was other stuff left out of the free tier that we saw, like advanced logging, I believe, and a couple other features that I would kind of expect to, yeah, sure, that can be left out of the free tier. I'm actually very surprised that multi-site management is not left out of it, so I guess I can put that into the pros here. You can have multiple sites on your free Omada cloud controller, but again, you can't configure the firewall rules, so I would expect multi-site management to be left out of the free tier, because if you're doing multi-site, you might be a business or you might be an MSP, so you should probably be paying for the higher level of service in that case. I would think that makes sense, but I think leaving firewall rules out of the free tier, again, is crazy. So the whole point of Omada is to be easy to set up, and it's targeted towards like hotels, small businesses. I mean, in general, it's targeted to a business-oriented sector, so this isn't supposed to be for home use. And pretty much any business environment is going to want multiple VLANs, and they're going to be highly concerned about security. So the free cloud controller being the selling point is almost moot when you can't configure the firewall rules for it. So this is a bit of a weird one for me to really come up with a thought about it, because on one hand I really like it. Most of the features that it said that it would do well, it does well. The setup was easy, the configuration push was easy, the ZTP, I've already said all of this, but all of that was great. It worked pretty well. I mean, obviously I haven't thrown it into a production environment, but here in the lab it's working. Our test PC is working as normal. All of our VLANs seem to function. Our wireless is great. But on the other hand, firewall rules. Why is that not free with the Cloud Essentials controller? Now, all of this can really be kind of wiped away with forgetting about Cloud Essentials and going with either the hardware controller or the free software downloaded controller. If I was just to download the Omada controller, put it on a server or a PC somewhere, I would have all those features already. Everything would be great, except for zero-touch provisioning. You can't do that. The self-hosted controllers, I don't think. Let me just double check. Yeah, zero-touch provisioning is only available on Cloud Essentials and Standard. So that being the biggest selling point is kind of what makes this a weird recommendation, is that with the standard way of doing things, you get everything except zero-touch provisioning, which is the thing that TP-Link wants to push as the big feature. But on the other hand, using their free cloud controller to get zero-touch provisioning doesn't get you really any security features. So you're almost forced to pay for standard, which again, I don't know how much that costs. It just says a per device license. I don't know. I know what that means, but I don't know what the cost would be for that. So when you compare this to, say, Ubiquiti, which this functions and works almost identically to, sure, you have to pay for their cloud controller service, but it's posted right there as you sign up for it that it's going to be X amount a month and you get to manage X amount of devices. So is that better or worse than paying per device on the not free Omada cloud controller? I don't know. I'm a little bit torn between that. But also, Unified doesn't technically have zero-touch provisioning, although you could very easily achieve almost the same thing with a very minimal setup. That's a whole other topic though. So I guess on this one, I'll just leave that up to you. Would you rather have the easy cloud hosted zero touch setup and just not be able to block anything like threats or even basic firewall rules? Or would you rather just pay for the paid service or deal with the on-premise controllers and ditch zero-touch provisioning entirely? Seems like a personal preference to me, but anyways, this video has gone on long enough. We've seen how to set up a complete network using Omada. We've done a little bit of troubleshooting. We've looked at some of the different ways you can use an Omada controller or deploy an Omada controller, and obviously the pros and cons of each of those. So this was a pretty big video. There is one more thing I want to mention. Again, I did get sent all of this equipment from TP-Link to test out, give my thoughts on, and make a few videos for. And there is one thing that they wanted me to mention, and that's that they're offering a limited time opportunity for qualified users to trial the Cloud Essentials solution for free. And what they've said is that would start with a free EAP 653 to explore the Omada Business Wi-Fi solution. So there's a link in the description to this offer. Basically, it's to get a free access point and try out the Omada solution. So if anything in this video interested you and you want to dive more into the Omada platform, take a look at that link. I feel like I shouldn't have to say this, but I have not tried that. No guarantees if you'll get your free AP. I would hope that TP-Link honors that and that there isn't any strings attached, but that is something I haven't looked into or vetted very much at all. I know that I have tried some of these promotions before from other companies, not TP-Link, and have never received my free equipment. So take that with a grain of salt, but that link is in the description if it is something that interests you and you want to give it a shot. So hopefully you learned something. Hopefully this gives you a little bit of something to think about when it comes to Omada. And as always, happy networking.